struggling to extend your Wi-Fi coverage across a large area? Or maybe you need to connect devices that don't support wireless networks. Whether it's bridging buildings or creating a seamless mesh network, wireless topologies like repeaters, bridges, and mesh networks are the answer. In this video, I'll show you how these technologies work, how to avoid common pitfalls like signal interference, and how to design a network that covers every corner of your space. Ready to take your wireless network to the next level? Let's get started. In this course, we'll look at other wireless topologies, as well as different modes of operation. Typically, each access point in a wireless network is wired to a distribution system, DS, or to a dial-up infrastructure, such as a switch. To extend the wireless coverage beyond the access point area, you need to add more access points with the necessary cabling. This can cause some problems if the distance is too great to handle Ethernet communication. For this reason, it is possible in this case to add additional access points that will be configured in repeater mode. This mode simply allows you to take the signal it receives and retransmit it to a new area around this new equipment. The idea is to position the repeater to be worn from the access point, as shown in the diagram. If the repeater has only one transmitter and receiver, it must operate on the same channel as the AP it is using. The problem is that in this configuration, it is possible that the signal from the AP is received and retransmitted by the repeater, and then received again by the AP. This reduces the flow by half, because the canal will be occupied twice as much. To avoid this problem, it is necessary to use a repeater that can use 2 transmitters and 2 receivers in order to isolate the signals of the AP and those of the repeater on 2 different channels. In this case, one transceiver pair is dedicated to signals in the AP area, and the other pair is dedicated to signals in the repeater area. Work-group bridge, WGB. Now we're going to see a device which is called a Wi-Fi bridge. It is found in its definition in English with the initials of WGP. This module is intended for all termination equipment, which has a wired Ethernet link, but is not capable of having a wireless connection. This type of equipment is often found in hospital settings. For this reason, a bridge is used, which allows the device's wired network card to be connected to a wireless network. This module acts more like a wireless network adapter, but it does not provide a BSS, basic service set. On the diagram, we can see that the AP provides a BSS. The laptop on the left is a wireless client, and the device on the right is associated with the AP via the Wi-Fi bridge. Among the WGBs, there are 2 kinds. We have the universal bridge, which is found with the initials of UWGB, where a single wired device can be bridged to a wireless network. And we have the WGB, which is a proprietary Cisco system, which allows you to connect several wired devices to a wireless network. Now we're going to see the outer decks. An access point can be configured, such as a bridge, to form a single wireless link from one LAN to another over a long distance. This type of linkage, bridged externally, is often used for connectivity between buildings or even between cities. An access point, configured in bridge mode, is required at each end of the wireless link. And special antennas are deployed to concentrate the signals in the same direction. This maximizes the distance as shown in the diagram. There is also another type of bridge, which is the multi-point bridge. Sometimes, LAN networks at multiple sites need to be linked together. A multi-point bridge is used to bridge a central site to several other secondary sites. The central site, the one represented by the building in the middle, is connected to an omnidirectional antenna. That is, its signal is transmitted equally in all directions, so that it can reach the other sites at the same time. And the secondary sites have a directional antenna pointed to the central site, as shown in the diagram. The last type of topologies we're going to look at is the mesh network. To provide wireless coverage over a very large area, it is not always practical to wire all access points via Ethernet. This is where the mesh mode comes in. In this type, several APs will be configured in mesh mode. Here, the wireless traffic will then be bridged from AP to AP, like a daisy chain, even using different channels. Typically, each mesh access point will have a BSS on a channel, on which wireless clients can associate. At the edge of the mesh network, the traffic link is bridged to the LAN's wired infrastructure, as shown in the diagram. With Cisco APs, you can create an indoor or outdoor mesh network, which will run its own dynamic routing protocol to determine the best path to mesh access points.